Okay, hello everyone. Welcome to our session. So today we are talking about the Linaro Developer Cloud update, and we are mainly introduction of our newly hardware automation. So today we will have two presenters. So first is me. My name is Kevin Zhao from Linaro LVC20, and also Xin Liang.
Hi, my name is Linaro.
Okay.
Yeah.
Okay. So our session is about two parts. So first is about the Linaro Developer Cloud. So it is a general introduction for our infrastructure as a service and also the platform as a service. So after that, we will have a detailed talking about the hardware automation technology in the Linaro Developer Cloud. So our Linaro Developer Cloud is a totally open source cloud for the upstream developers and also the open source community. So we are build the open source infrastructure as a service and also offer the platform as a service on top of the latest ARM-based server class hardware. So now we can enable the mainstream environment and enable the IoT edge and cloud ecosystem to develop port and enable the CI/CD for the ARM ecosystem. So now we are a totally OpenStack certified cloud because the infrastructure as a service is based on OpenStack and Ceph. And also we can offer the Kubernetes as a service. And recently we have been certified by CNCF. So this page is general architectures for our cloud and the service we can offer to the upstream. So we can see the basement of the cloud is OpenStack and Ceph. So OpenStack for computing, for the networking support, and also Ceph for the backend storage support. So on top of this, we can offer the user three main workloads. So first, you can have a virtual machine. It is a totally isolated TNet isolated virtual machine instance. You can do whatever you want, and also we can offer the Kubernetes as a service. So you can have a totally open source the Kubernetes cluster on top of the OpenStack, and you just need one API to launch and manage your newly created Kubernetes. And also we can offer users to the custom workloads. For example, you want to deploy several workloads or deploy your applications in the Linaro Developer Cloud. So you can define the template, or you can deploy the application on the Kubernetes cluster. So on top of the totally Kubernetes cluster, we can offer UI for the user interface, and also we can using the OpenStack SDK for the tenant for the different users to use. Next, so this picture is mainly Linaro Developer Cloud architectures in details. So in the bottom of the picture, we can see it is ARM64 bare metals, and on top of this, we use the Colo-based OpenStack and Ceph. So because that the OpenStack and Ceph are the infrastructure service, so they are not very easy to deployment. So using the Colo-based container will solve the compatible problem. So after the infrastructure is ready, we can see in the green module, so the OpenStack has offered several services. For example, the Nova, the Neutron, and Keystone. So many of them are offered the network, compute, and the volume support for the VM instance. So after that, to achieving a Kubernetes service, we also have a lot of the have several new components in the in the block. For example, we use the Magnum to provision the Kubernetes provisioner, and the Octavia for the load balancer, and Hate for this orchestration service. So because Kubernetes is famous now, and a lot of the providers can offer this function, so we are leveraging and developing the open source solution on ARM64 to offer the Kubernetes service on top of OpenStack to launch the Kubernetes cluster. And after the Kubernetes is ready, what we need is that using the Kubernetes, and also we need to interact with the OpenStack infrastructure. So as we know, the OpenStack cluster. So we also need several controllers to handle the resource interaction with the sender, with the network. So we need several red block. We can see in the picture, it is a OpenStack cloud provider. So it is a cloud controller manager, the sender CSI driver, and also the Octavia ingress controller, which is served for the load balance service for the application that will be deployed in the Kubernetes. Also, for open source cloud, we know that the monitoring are very important. So we are using the Prometheus and for the totally monitoring. So we can see that all our solutions are totally open sourced. So next, I will cover several user scenarios for our Linaro Developer Cloud. So first is the most traditional. The user can access the virtual machine by attaching the floating IP for the instances. So the different users can have multiple virtual machines in the shared network, while the different tenants virtual machine are isolated. So the user can either use the UI or API to access our Linaro Developer Cloud for the management. And in the right picture, we can see there's the two main user cases for us. So first is OpenLab and OpenDive. So they are leveraging the LDC as a node pool. So when the CI job running, when the CI job coming from the OpenLab or the OpenDive, so they are calling the OpenStack API to our LDC cloud, and then the CI job will come in, and they will launch the virtual machines in the Linaro Developer Cloud, and then running the tasks. So because it is a auto scaling framework, so they are traditionally provision VM running the job and delete the VM after the job is finished. So another use case is more stable. So we have collaboration with the Apache Big Top project. So they have a central Jenkins master, and the VM will pre-creation the virtual machines in LDC and served as a slave to running as the CI jobs. So the virtual machines there are more stable and dedicated for the test. All right. So next is a user scenario that is more dedicated for deploying the generally workloads. So we can see in the first picture, it is a user. The user want to define have defined two virtual machines. The VM1 is with the container installed and running the MySQL container, and the VM2 is with the container installed and running the engines. So we can define the Hate template to generally provision the virtual machine, and after the provision, they can define to join the container. In the VM1, they will install the Docker container and pull the MySQL containers and run the MySQL. And also in the VM2, the Hate template will tell the OpenStack to install the Docker container, and after that, run the Nginx container, and also access to the MySQL container port. And also, we have defined the floating IP to the VM2, and so for the users, they can get access to the Nginx, to the Nginx server by accessing the virtual machine 2. Another use case for, say, the Kubernetes, we can say it is very simple. So user can use one API to provision the Kubernetes. So the only parameters for you is just specifying the node count and also the Kubernetes version. So after that, they can deploy the Kubernetes cluster for you only once with one command. And after that, the OpenStack will generate the kubeconfig files, and you can connect with the Kubernetes clusters. All right, here is a last scenario, which is a little more complicated for the developers, but it's also very important because traditionally now, there are a lot of users are tending to deploy their applications in the Kubernetes cluster. So, so we are also design these users scenarios for the upstream developers. For example, you want to you want to deploy your Nginx with a MySQL container and also want external access. So we can say first, you need to define the Kubernetes YAML example. So you need to define the pod, which has a container 1 with a MySQL image and container 2 with the Nginx image. And also, we know that in Kubernetes, pod is not a pod is a beta unit, but it is not the expose unit for the total service. So you need to define the deployment concept, which has been specified to the pod. And after that, we need a service concept, which is related with the deployment, with this deployment. And after that, the service can be accessed to in the in the Kubernetes eternally. But if you want to have a external access, you also need to leveraging the OpenStack resources here. So we need to define the ingress concept here and cite the backend service to the SVC we have defined before. So after that, we can using the OpenStack Octavia ingress controller. So this controller can have create a load balancer in the OpenStack side. So after that, the OpenStack load balancer can be attaching a floating IPs. So user can access by the load balancer from OpenStack to the ingress, and after that, the flow will be connecting to the Nginx container. So it is a relatively long data flows. So you need to specify the path level, the Kubernetes side, and also leveraging the infrastructure side as a OpenStack. Okay, so here is generally 3 scenarios for us. And now, actually based on our work with OpenStack and the Kubernetes, we are now certified by the CNCF side. We are actually the CNCF certified cloud. The next is the CI collaborations now with Linaro Developer Cloud. Actually, we have a good relationship and the collaboration with OpenLive as a node pool, and also serve for the Jenkins slave with Apache Bigtop, Apache Beam, and also we are collaborating with Zephyr and RPM Fusion. And actually, we can offer the ARM-based open source CI resources. So we welcome the other upstream if the newly upstream have the interest to build or the site or develop the ARM-based application or solutions. So we welcome the applications. Okay, so next I'll hand over to Xinliang. So he will talk about the hardware automation.
Okay, thank you, Kevin. Let me present the second part, hardware automation. Please, next. Okay, when we come to hardware automation, we are mainly talking about the bare metal provision because we mainly handle servers in the data center. Here are some reasons why we need it in our Linaro Developer Cloud. First, there are some limitations in nested virtualization. That is, some advanced feature or functionality such as GPU are not working in a nested virtualization. And nowadays, the private cloud are attending to bare metal plus Kubernetes for best performance. And also, the external CD and CI users request for the bare metal machine. Yeah, these are the reasons why we need bare metal for our Linaro Developer Cloud. Next. Okay, this picture is the overview structure of our bare metal provision solution, which we are working on now. We use Ironica, the main bare metal provision project, and Cinder with a step to provide the remote iSCSI volumes for the bare metal machines. And in the bare metal machines, they are all disk-based. That means this bare metal machine just put from remote set volume. Okay, next. Our main level is to make metal machine to put from remote set volume. Here is the brief view of how Ironica use set volume. First, in the rightmost, there will be a Cinder. There will be a set iSCSI gateway to provide the set iSCSI value. And in the middle, Cinder. In the Cinder, there will be a set iSCSI driver to communicate with the set iSCSI gateway. And Ironica call, and at last, Ironica calls Cinder API to fetch the Cinder value, connection information, and attach to the bare metal machine. Okay, next. This is the inside how bare metal use set iSCSI volume. As you can see, we have a control pad on the control node, which handle volume creation, attach, detach for the set iSCSI gateway API, and also in the bare metal compute node, we have a data pair to read and write the remote iSCSI volume disk through the iSCSI initiator and the targets. Okay, next. Okay, now that the user can launch a better machine just like they do for VM, and this work is under internal testing now. And also, if a parameter want to access the outside internet, they can use the floating IP as the VM too. Okay. Next. Okay, thank you. Thank you for listening our presentation.